Right, hi everybody. I'm going to do it from the notebook today to see how that works, to see if it's any better than using that board outside. It's a bit difficult to get all the information on that board outside. So today we're going to have a look at resistivity, and in your line of work that really refers to the resistance of cables, because that's what we're mainly interested in the electrical distribution business, is cables. So what we've done so far, we've done resistances in series, and in your particular area that really refers to the resistance of cable length. Because a piece of cable is made up of conductor material, and it's a bit like stringing lots of resistors all together in a line, in a chain. So the longer the cable, the more resistance you've got in that cable. So what we know is that with a piece of cable, we plotted a graph of resistance versus length. We'd find a straight line like that, a bit like Ohm's law. As we increase the length, the resistance of the cable goes up. However, if we looked at the cross-sectional area of the cable, and some cables are very thick, like this one. This is an earth cable, it's very thick. And some cables you'll come across are very thin. You'll mainly come across those in control situations. But in your industry, you're more likely to come across very, very thick cables, maybe up to 25 to 50 millimeters or more square millimeters in cross-sectional area. So now if we have a graph of the resistance versus cross-sectional area, we get what we call an inverse graph shaped like that. So we can say that the resistance of a piece of cable is directly proportional to its length and inversely proportional to its area. Now we've got to have some constant here to work from, because we need to know what a unit of this material, say copper, is, and that is given the term rho, which is a Greek letter rho. And the resistivity of a material varies from material to material, and you can see on this chart that the different materials have different values of resistivity. So what resistivity, or what rho actually means, is what is the resistance of a unit, a cubic unit of material. Now the SI unit of material, the SI unit of volume is the cubic metre. And a cubic metre is actually too inconvenient for us because it's just too big. So it's easier to work in millimetres. So the cross-sectional area of a cable will be measured in millimetres squared. And its length therefore has to be expressed in millimetres as well. So when we're doing some calculations, remember to use millimetres throughout. Particularly important on City and Guilds exam for this particular course, because they will give you or expect you to work in millimetres, not cubic metres. When I was at college, we used to have to convert them to cubic metres, not cubic millimetres. Okay, so we're getting on for time. All right, what are these constants then? Well, for copper is, for rho, for copper is 17.2 times 10 to the minus 6 ohms per millimetre cubed. And really, if you Google that figure, you'll get lots of different figures, but they're all approximately around that figure. So the figure that the course is expecting you to use is 17.2 times 10 to the minus 6. And that's normally given in exam questions. You don't normally have to remember that. Okay. So, if, for example, we had 100 meters of cable. There's our cable length, it's 100 meters long. And it's, let's say it's 25 millimeters squared CSA. What is the resistance of that cable? Well, there's the formula. And we simply substitute the figures. The resistance will become rho, which is 17.2 times 10 to the minus 6, times 1000, because we've got 100 meters times 1000 is 5 noughts on the end here, so it's actually it's 100,000, isn't it? So it's 100,000 millimeters, or you could call it 10 to the 5 if you wanted to. And you divide that by the area, and all we have to write in is 25. Because we've converted everything to millimeters, we just write in 25. And 17.2 exponent minus 6 times 100,000 divided by 25 gives me 0.0068 of an ohm, which is probably about right because 25 millimeter cable is quite thick. Okay, there we have that one. Time for one more. 100 meters of copper cable, 100 meters, let's say it's 2.5 millimeters squared, resistance equals rho L over A, put the figures in, 17.2 times 10 to the minus 6 times 100,000 divided by 2.5. Is 6.88 ohms. Okay.